Select the major products of the following reaction. So whenever we're asked to select the major products of a reaction, we need to break down what we have. So we're going to always look to what our reactant is, and we're going to always identify it by the functional groups that it contains. So we can see here that we have a carbon-carbon double bond. So this is an alkene. And we identify the functional group of our starting material because we organize our organic reactions by functional groups. This will help us to recall what it is we're looking at. And so we see here that we have hydrogen gas and we have palladium on carbon. So these are the conditions for a hydrogenation. So the palladium on carbon is the catalyst for this reaction. So this is the catalyst. And so how the reaction takes place is you basically have the metal. So that is the catalyst. So this is palladium on carbon. So this is a solid. It's a heterogeneous catalyst, meaning that it is not dissolved in the solution. And so what happens is that the hydrogen molecules kind of come and settle on the surface of the metal. And this is how the metal is going to catalyze this reaction. And the reaction takes place on the surface. So you have your alkene. So I'm just going to draw generically an alkene. And essentially what happens is this comes along and both hydrogen atoms are transferred at the same time. And so we can draw some curved arrows. These are not the actual mechanism arrows, but we're going to use this to help us visualize. So those would be going back to the metal and then these electrons. So make a note that this is not an accurate mechanism. Okay, so even though it's not quite accurate in terms of the curved arrows, we often see that with metal catalysts, we can't quite draw the same sort of reaction arrows that we do when we don't have a metal catalyst involved. But nonetheless, both hydrogens are transferred at the same time, and this is an important piece. So both hydrogens are transferred at the same time. And so why that's important, so it's concerted, that's one way that we can call this, at the same time is known as concerted in organic chemistry. And it also means that they're going to be transferred to the same side, so we also call this a syn addition. Right? So if your alkene's coming along and sitting on the surface of the metal, they're both going to go to the same side of the alkene. There's absolutely no way for this to like flip around and one end up on the other side. And so that has ramifications in the stereochemistry, right? So if we're adding two hydrogens to this, we are definitely making an alkane, right? So we are reducing that alkene to an alkane. But it also means that both hydrogens are going to add to the same side. And so these two methyl groups then would also be pushed to the same side. And so what we would see then, right, is we could draw maybe the two methyl groups as sticking out and the two hydrogens as going back. Okay, and of course the opposite scenario is also just as likely. We could have the two methyl groups going back and the two hydrogens sticking out, just depending on what side of the alkene happen to sit on the metal. But hopefully you can recognize that this is a pair of meso compounds. These are the same as each other. So you only need to actually draw one of those. And so then if we look at our options, we should recognize that this is D, representing that meso compound. And again, I'll draw in the hydrogens. So you can see that the hydrogens are on the same side of the alkene, which has pushed those methyl groups to also be on the same side.